right, on students, we're going to cover this one little extra bit of information that you need to kind of be familiar with. And the formula is written here. Density is molar mass over molar volume. It's just another formula that you can use to help you to figure out one of these things. So let's just use this really quickly. It's a super easy concept in this question. 1 mole of an unknown gas has a density of 2.144 grams per liter at STP. Remember, it has to be at standard temperature and pressure for molar volume to work. Remember, the molar volume is 22.4 liters is in 1 mole, or 22.4 liters is in 1 mole written this way. So this is only good at STP, standard temperature and pressure. Standard temperature is 273 K or 0 Celsius, and standard pressure is 1 atmosphere, or anything that equals 1 atmosphere, which is in your notes. So let's work this one out. Density equals the molar volume over, the molar mass over the molar volume. So what we have here is density, so 2.144 grams per 1 liter equals the molar mass over the molar volume. Well, the molar volume I know, 22.4 liters. So I just have to solve for the molar mass, which is the question. So multiply both sides by 22.4 liters. Okay, notice they cancel on this side, and the liters cancels on this side. And the molar mass of my unknown gas is 48.0 grams per mole. Now that's what the book has when they did this work, and because 22.4 liters is a definition, I wouldn't use that as my sig figs. I would use the 4 sig figs. So if we pull up our calculator, let's look at the raw answer. I was trying to cheat real quick and not have to do this, but 2.144 times 22.4 is 48.0256. And so now we're going to look at sig figs from the measured value. And that's 4 sig figs. 1, 2, 3, 4. So 48.03 grams per mole. Because this is over moles right here. So it's liters over moles. So the liters cancel, grams per mole. Right, so that's the molar mass of our unknown substance. Now, I hope you understood what I did right here. When we're dividing, it's really this whole thing that we're dividing by, the molar mass, that many liters per 1 mole. And so we multiply both sides by that entire quantity. And so on over here, when we do it, the liters cancel, but notice grams and moles are on the bottom, and that's the units for molar mass, so that's good, grams per mole. All right, so let's try this next one. What is the density of chlorine gas at STP? Now remember, chlorine gas, chlorine is Cl2, but they already gave us the molar mass, so you just have to calculate the density. So density equals molar mass over molar volume. All right, I want you just to calculate this yourself. So once you've got that done, then I'm going to calculate it for you. And you'll have to enter, because you have to enter in your value. All right, so the density. So what's the molar mass? They already gave it to us. 70.90 grams per mole divided by the molar volume, 22.4 liters per mole. And then we do the math. The per moles will cancel because it's one on the top and one on the bottom. It's this is a complex fraction. I'm not going to worry about showing you all the specifics of the math here, but I think that you should know this. And so then the only things left is grams per liter, okay? And that's a density unit, grams per liter. So we just have to pull it up and put it in. See here that I did it, and it's 3.165. 3.1652. Okay, again, the measured value. In this case, there's really not any measured values. Both of these things are kind of definitions. So I'm going to go ahead and go with the smaller sig figs. I will give you some grace on this sig fig issue. So 3.17 grams per liter would be the answer to this one. All right, now we're going to do what's the density of bromine gas. Now you have to remember, I put this without the molar mass because you're going to have to calculate it out. Remember, bromine gas is also Br2 because it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine. So if we're going to calculate the density of bromine gas, we need to know the molar mass, and we already know the molar volume. So you need to calculate the density of bromine gas, and then calculate the the molar mass of the bromine gas. Put it here, and then calculate the density. So do that for a moment, and then I will do it for you. Okay, did you get it? Here's the answer, 7.13 grams per liter. All right, that's all we need to do. See you soon.